Hello, this is Ron Woodward recording for Intel's Digital Logic course. This is Lab 2, Part 1. And in this part, we needed to have two sets of 4 switches that were connected to the 7-segment displays, two 7-segment displays. So essentially, the 4 switches would act as a 4-bit binary number, and that would be decoded onto the 7-segment display, and that should handle values 0 to 9, at least for this one. I know in Part 2, we're going to be basically translating it so it actually supports all the way up to 15, which is the greatest 4-bit number you can have. But in this lab, we just needed to have it where you can flip, let's say, switch 0 to 3, and then you could flip switch 4 to 7, and 0 to 3 corresponds to a single hex display, and 4 to 7 corresponds to the second hex display. And so we could type in, let's say, or flip up the switches to have maybe 1 on hex display 0, and then maybe we want 5 on hex display 2, and those will be independent of each other. Alright, so the VHDL code and then the Verilog code. So in the VHDL code, I just have 4 ports that I declare. I have 2 sets of 4 switches here, the input switch set 0, switch set 1, and that's 4 switches for each. And then I have 2 hex displays that I've declared, hex 0 and hex 1, and those are obviously 7-segment displays. I use a architectural model here, although it says behavior, because I am just in the habit of typing behavior rather than actually pointing this out, obviously, that this is a structural model. But I have declare a component of the same BCD 7-segment decoder I've used in previous labs. Here's the code for that here. And the only adjustment that I made is to have 9 display if anything greater or anything other than 1 to 9 is displayed. So if someone tries to type in 10, 11, 12, 13, 14, or 15, we get the value 9. So those are basically ignored. They're not important. The actual term for the value is, I think, don't care. Is like that's a don't care value. But aside that, we declare that component. We instantiate that here. We have 2 intermediate signals. Now, I know you don't have to do this. We could just put hex display 0 and hex display 1 here on the outputs. But I prefer to have an intermediate thing. I've had some issues, for instance, with we're using buttons because, or no, excuse me, not buttons, switches. Switches are not generally debounced, at least on this board, and buttons are debounced. So it can throw off some simulations if you don't have this intermediate signal. It just kind of adds a step for the process, and that seems to fix a lot of issues I've had in the past. But irrelevant. We just create 2 instances of the BCD 7-segment decoder, and we map those 4 switches for the inputs. As we can see, our inputs for the BCD in are right here, 0 to 3, and then our outputs are M0, M1, which eventually get assigned to those hex displays there. And similarly in the Verilog, as I always say, the VHDL is incredibly easy to move on from Verilog. Personally, I favor VHDL, that's why I always start with it, but Verilog is very easy to go to after you've done the VHDL. It's very similar, but in this case, I didn't declare an intermediate signal. I just have the 2 hex displays posted here, and this worked just fine. I actually will be demoing both for the sake of a friend who's curious about this stuff, but to show that I have the Verilog done and ready. It's the same input, same output, same names. I just had to build this in a different project so I could actually run it using the Verilog. But that's it for the code, and the demo will be starting here. Alright, and here is Lab 2, Part 1. We have hex 0 and hex 1, and I do believe I actually have them backward. I mixed up the pins. I wasn't paying too close attention on the numbers, but if we want to play with hex 1, we'll be doing the switch set 0 rather than switch set 1. I'll make sure I flip that around for the next demo. But nonetheless, we can control each of these 7-segment displays independently, and we will do so just by doing this. So let's say we wanted to see, I don't know, 2 on that left, so we'll see 2 here. And then maybe we wanted 5 on this one on the right here. So we could see 5, but that will pop up all the way to 9. Even though this value is actually 15, it will only say 9. So maybe we wanted to show 10, which is 1, 0, 1, 0. We only see 9, so that's that. And then similarly on the left hex display here, we'll see 9, and maybe we want 15 or 14, something. it will only show 9. That's the absolute max. So we have 8, 1 to get 9. Maybe we want to bump that up to 9 or to 10, but it won't show because of 9. All right, and that is it. Thank you.